Hello, this is Group 13. We did the power consumption final project. We chose this project because we thought it was interesting going over the different zones and how each zone will consume power in its area. So going through this project, we started looking at it and we started looking at the objectives. We broke down who's going to do what. Enze did the last end of the code, doing a lot of the inputs and looking at all our codes and fitting it together. Me and Mahmoud, we did a lot of the zones and finding different models that would help fit our project. Going through it, we just decided to split it up that way. It just seemed to happen that way. I mean, you can see right here, we first started with the linear regression. So we imported all the necessary libraries that we were going to need. We figured we might as well do it in one cell to make it more efficient. And then first things first, from the basics, we just loaded our code and then we started reading it and describing it. This is a lot of information we gained from the labs. So you can see here, we even plotted it just to show a wide spread of like what each zone was looking like in its current state whenever they got the readings. And moving forward, we then started using the linear regression on zone. Well, no, this is correlation, but it ties into the zone one linear regression. We found the correlation of the models. Then we had the coefficient, plotted it. You can see we had a heat map here, and then it ties into linear regression. And then we used that model and applied it to the other zones. So this would be zone one's correlation map. And, now we're going over zone two. And when you look at it, we wanted to do it because it was a basic first step. And you can see how some of the linear regression lines run steeper than others, and some of like the groupings of the data is more spread. Like zone two had a wide spread of data, while zone one had a linear one. Um, and then we apply the same ideals to zone three. Manipulated the code accordingly. We did all the necessary stuff. There's the heat map. And it seemed that zone three also has, it seemed to be a little lower than the others, but we couldn't account for any other variables. But I digress. So I keep going, please. Um, yeah, it kept going, and then we decided to go with a big model, ARIMA, and we wanted to do this so we could see it on a really wide scale. And I think it proved effective because this is over a 30-day consumption forecast. And since we are talking about power, I think us as a like society really uses a lot of power from a day-to-day life. To prove my point, if we go to zone two, you can see that well, we see that we applied the different code and manipulated, but the result is the later end of the graph is it rose more and zone one decreased. So that helps us realize what they do in zone two. This is the 30-day consumption. So in just a 30 span time, it's still a greater number than zone one. But then we move on to zone three. And I mean, the code is all there. We plot, we do most of it. It's like clear cut. This is why we were glad that we used this is why we're glad we used Arima, because especially when you look at zone three, you can tell the different usages and how which proved effective and which didn't. That helped us in our model and in our final input. So I think that it was a good pick, and I made sure to spread it with my group members for to get their data. Um, and yeah, now we're gonna pass it to Ahmad.
So for my model, you gotta. So for my model, I decided to do a decision tree, and so you can see I loaded in all the data I needed to. I plugged in the X data types and the Y data types, my features and my target. I loaded the model up, and I just trained the model using that data. And as you can see with the visual representation, the reason I chose the decision tree was because it was just different. A lot of the models I seen were, kind of linear based. And for a decision or for a predictive algorithm, I kind of wanted to go a different route. So the decision tree to me, it's like it'll take one value. If as you can see the top value at the very top of the tree, it says if this data is equal to or greater than, it'll break into different branches, and so it just keeps getting more and more specific, and it gets it's really interesting to just see like how it ties into the predictive. It's not really that what's the word? I guess pretty when it's in a visual format, but the code itself is just as effective, or it's very effective. So as you can see, I ran it through zones 1 through 3, the different data. You're not going to see the difference in data or like the visual difference in data, but the if you look inside the boxes, you'll see the data that I pulled from is different and is changing. So it really it just goes into the whole predictive thing. Like visually, you're not going to see it, but when you run it through the predictive algorithms and input your values, you're definitely going to see the decision tree making those predictive values.
All right. And um, okay, can I go now? Okay. So, like Quasi stated, I worked primarily on the input function. So what I did here was I con constricted the data into just three X's, temperature, humidity, and wind speed. And this is the data, or yeah, this is the data that I will be using for zone 1, zone 2, and zone 3, predicting the power consumption. Um, Here I fit um the this value into a standard scalar. I transformed I trained the X, and I implemented the linear regression. And utilizing all this, um uh, I defined get user input to um make it just effective and just the way it looks. Enter zone number 1, 2, or 3. If it's invalid, then you will get the invalid zone. And please enter 1, 2, and 3 output. Um, and I can run it right now. One, two. And with that, you have the output calculating all the gathered data from the previous code, and combining it to get you know, your power consumption estimator.
Yeah, that's our project. We all went over it. It was a great experience, and that's the end of Group 13's project.